Now, as we go on to section 2 of chapter 5, again, this is another one that's not included in our curriculum, so to speak, because this used to be covered in Math 100. So, again, I strongly advise that you look it over because you will need mastery of these skills to do the next few sections that are required. And we have multiplication now of polynomials. First, multiplying monomials, a monomial and binomial, multiplying polynomials, the special multiplication process of two binomials called the FOIL, squaring binomials, the product of the sum and differences, and then a review of function notation. Again, I don't want to make this too long. It's just a review, but going over the examples as we look at them. So in example A, you're asked to multiply two monomials. Notice here the coefficient is -8. Here it's 5. So a suggestion would be always do the sign and the number part first. So you're going to multiply these two. So a -8 times 5 will be a -40. Now for the variables, we're just going to add the exponents. 4 plus 3 is 7. Y to the 7th plus 2, y to the 9th. So that's pretty straightforward. Now for letter B, as we look at it, we have a negative times a negative. So that's going to make this a positive. So now you don't have to worry about the sign, it's positive. 3 times 4 is 12. And again, just adding your exponents. 5 plus 2 is a to the 7th. Remember there's a 1 there. B to the 6th. And C to the 14th. So that's pretty straightforward. Now, when we multiply a monomial by a binomial, we're using the distributive principle from way back in algebra, and they're showing it here nicely. This times this gives you 6x squared. Now watch the sign. A positive times a negative gives you a negative 10x. Here again, the same thing. Carefully watching the signs, you get your answer. Now, an interesting thing that we'll be using a little later in this chapter, we'll be taking this and think of it as a product that we got by multiplying something, and we want to factor out the greatest common factor, which happens to be 2x. And when we factor that, by taking a 2x out of each term, it goes back to what we started with. So again, that's coming up in chapters we will be doing, or sections we will be doing, and then in chapter 6, we're going to use quite extensively. Now here we're going to multiply a binomial by a binomial, and they're doing it in a horizontal form. Now I do it a little differently, and I'll show you the way I do it usually. And you can do it either way, and again, there's more ways to do it. That I would take this first term, which is y to the third, and times it by this. And then I would take this second term in the first binomial and times it by this. And many of you may have learned it this way. And then we just distribute. Now, another way, again, they're not featuring it here, but it's to take the top row, 2y to the third plus 4, and then underneath it put 3, or y to the third minus 5, and you're going to do it vertically. In fact, you get the same answer either way, but this way, and this way. Let's look at it this way. Negative 5 times a positive 4 is a negative 20. A negative 5 times 2y to the third is going to be a negative 10y to the third. Now you multiply this one. This one times this is a plus 4y to the third. And notice I've put them in like term columns, which is going to be a useful skill here. And now this times this gives me a plus 2y to the sixth. And now you just add them up. So this will be a 2y to the sixth minus 6y to the third minus 20. And you get the same answer. Either way. Now, this technique here, though, will be something we'll be doing a little later in one of the required sections of Chapter 5, where we're going to factor by grouping. You'll see we do something like this, that notice there is a common factor there. So we'll put this common factor there, and then pick up on this and put that in another parenthesis. So a lot of this stuff we're going forward in multiplication. Later we're going to do factoring. Now, when you multiply any two polynomials, there is a protocol or method to follow. Again, we can take the p and multiply it by this, and then the 2 and multiply it by this. But again, I'm here to strongly suggest that when you set this up, set it up vertically. P to the fourth minus 2p to the third plus 3, and then underneath it, you're going to put p plus 2, and you're going to multiply. Now you get the same thing, except you get the like terms lined up vertically, and then you can add them very well. Again, some of these can be confusing, so you want to develop a technique that you get the right answer. Now, here they're showing you the vertical multiplication technique. You could have done it horizontally, but it strings out quite a bit. So by doing it vertically, and they're also introducing another key thing, and then that is to be sure to leave spaces when you have a missing degree. So here's the first. When you did your first row, because there is no second, you have to leave a space so that they will line up in like term columns. Okay? And keep in mind here you're multiplying. The variables do change as you add exponents, but once they're in like term columns and we're adding, the variables don't change. A good little technique to keep in mind. And now we're going to take a look at that special way of multiplying, which is called the FOIL. And basically what it means is as you set up your two binomials, the x here and the x here are the first terms in the parenthesis. That's the f. You multiply them. Then the O refer to the first and last, that is the outers. Then the I for the inners. And then the last would be the second member of each binomial. Now all that this is a special way of doing it. And this is going to be very important in later sections in this chapter where we have to factor a product and then get it into its factors. So we have to reverse this eventually. But there's the FOIL. And you'll have practice on this. So they're showing you once again the FOIL method. Now, they have a lot of examples worked out here. Let's do letter B, I should say. So what you might do, even on your paper, is just make a little line. These are the first. So that's going to be 2x squared. Now the outers would be these, which would be a negative 8xy. The inners, a positive 3xy. And now the last, which is a negative 12y squared. Often the middle terms are like terms that you will group together. So your final answer will be 2x squared minus 5xy minus 12y squared, which is what they have here. And the process by which we did it was the FOIL. Now often if you get good at it, you don't have to write these two middle terms. You can do that mentally and go from this directly to this because you did this mentally. But in the beginning, as you develop your skill, I would suggest you write it out and then combine the like terms. Now later, we're going to take this trinomial and factor it back into that using various techniques, which we will go over and we will do as part of our course. Now, when you have three binomials, what do? Well, I would FOIL these two, and then once I got a three term, which is what they have here, I would use vertical multiplication to get my final answer. Here they're doing it horizontally, which is okay, but again, you want your answer to be correct. You don't want to save a little bit of time and end up with the wrong answer. You want to go carefully, you want to check your work, and give it your best shot. Okay, now as we look at these next few, we're asked to determine which of the following is true. Well, this one's not true. This one is true. This is not true. This is not true. This is true. And you might say, how did I know that? Well, I happen to recognize this, that this is a squaring a binomial, and then this is the product of that, and squaring this binomial, and this is the product of that. Now, a couple of things I looked for. Here is the middle sign positive. Yes. Is the middle sign negative? Yes. And a few other things. Okay, I want to keep the tape short if I can. Now, there is a pattern, a special way to multiply, and you could use the FOIL initially, but what I want to show you is the shortcut way, I call it. And that is the special way of multiplying a binomial that you want to square. Step one, now you could always do it this way by FOIL, but step one is to square this first term. Step two is to multiply these two together and double it. So you're going to get a 2, whatever that is. And notice this sign is there. And then you're going to square this last term. Now, this is called a perfect square trinomial that we see down here. Now, it's the very same if the sign is negative. The only difference is this middle sign here becomes a negative. This is also a perfect square trinomial. Now, what's the key of knowing this? Well, these factor into that. Okay. Something to keep in mind as we go along here. Okay, now they're showing you that special way of doing it. And notice letter C here is a real challenge. But you square the first term, get that, multiply the two terms together, get that, and then double it by multiplying it by 2. Notice here the 2's will cancel out. There's where you get that middle term. And then you square the last term. Now a negative 3 times negative 3 is a positive 9. And y to the 4th times y to the 4th, y to the 8th. You just add the exponents. Now I recently gave some tests and I noticed students, when they did this, were not getting the middle term. When you square a binomial, you get a perfect square trinomial. So you need 3 terms. Now, how do you get mastery on this? You get mastery by practice. And then you do your quiz me to earn those mastery points. Now, the next one is the product of sum and differences. This is also a special product, we can skip this part because we're going to look right at it. Now notice when you FOIL the sum and differences of the same terms, and by the way, these have another special name that I want to introduce at this time. They're called conjugates. And write this in your notes. These are conjugates of each other. That is, these two terms are the same, but the sign in the middle of one is plus, the sign in the middle of the other is negative. They're conjugates. When you multiply conjugates, notice what happens to the middle terms. You get a negative AB and a positive AB. They just cancel out. So you end up with a difference of perfect squares. Now the difference of two squares or perfect squares factors into their conjugates. So another little key to what we will be doing. So if you recognize you're going to be multiplying conjugates, then the products are rather easy because you don't have to worry about middle terms. And they give you some examples here. So here I would set this up vertically. Set this up vertically as well, or you could FOIL. Actually, these are conjugates if you arrange them a little differently. And this one you would have to FOIL. These are conjugates. Change their signs. Here you're going to expand this one by using that special technique and then grouping like terms. And the answers are all here as well. So since this is review, we're just going over it quickly to let you know these are things you're going to need to know to do the next part. Okay, function notation. Here we're saying that this set of conjugates equals that. And they could fit into a graph. If you put that into your graphing calculator, it would look like that. And here they're introducing something that I'm going to take a moment to look at here with you. That suppose this were 0. So what did we say the g of x could also stand for? It could stand for the letter y. So this is like y equals this. And if y is 0, which is what this is then, and we look at the graph of this, which is this, y is 0 right here, what is our x value there? Well, a negative 2. What is our x value there? A positive 2. So later in this chapter, we're going to be looking at where this factor and this factor equals 0, which is our y value, that what would this be? We'd say x minus 2 equals 0, or x plus 2 equals 0. Here we're going to get x equals a positive 2. Here we get x equals a negative 2, and that's where they get these. And we may or may not have mentioned so far I know we did this in Math 100 last term. We said we're finding the zeros when y is a 0. What are your values of x? And we're going to be doing this in sections in this chapter shortly. So that's just a little preview of it there. Now here they want us to substitute using this function these values. So let's see it worked out. So here we're going to go to our basic function and replace the x with an a and then add 3 to it. So x squared now becomes a squared minus 4x. The x, remember, is the a, so it becomes this. And then there was plus 5. And then it says add a 3. So we add a 3, and that's what we get for letter A. In letter B, wherever the x was, we're going to replace it with a plus 3. So we square this and get this trinomial right here. Put the a plus 3 where the x was, distribute that, and get these two terms. And then we add 5 to it and group like terms, and we get that. And here we have this function where we replace the x with this, and that's what we've done here. Then we're going to minus, replace the x with this a, get this, replace this set of terms because of this negative with the opposite sign, which is what they're doing. This becomes a negative, this becomes a plus, this becomes a negative. Here we're going to group like terms, and we end up with one like this. Now, this would be considered a hard problem. Generally, we're going to not do some of these very hard ones, and you may or may not expect one like this. I don't think you would have one, but there it is. And that completes this section.